Okay, so let's begin our discussion over the JEE Main pattern questions on conic sections. First question says if there is a point a comma minus a which lies inside this given circle, then a lies in which interval? The moment I say that a is lying inside the interval, this point is lying inside the very circle, we have the criteria with us, which is S1 is less than 0, right? So when a comma minus a lies inside the circle, S1 is less than 0. What is S1? In place of x, you put x1, in place of y, you put y1. Here x1 is a and y1 is minus a, and this LHL left hand side basically is going to be less than 0. So you get x square plus y square, which makes it a square plus a square minus 4 into a plus 2 into minus a minus 8 is less than 0, because the point is lying inside the circle. So its coordinates are going to not satisfy the equation of the circle, but when you plug in the coordinates of the point in the equation of the circle, you get less than 0 and not equal to 0. So you get 2a square minus 6a minus 8 is less than 0, which means a square minus 3a minus 4 is less than 0. Right? So what you need is a square minus 4a plus a minus 4 is less than 0, isn't it? So you get a minus 4 plus 1, a minus 4 is less than 0. So you get a minus 4, a plus 1 is less than 0, which if you plot on the number line, you get this is minus 1 and this is 4. If you plug in anything less than minus 1, you actually get positive, so you don't take this region. Here you get negative, here you get positive. So it is for x belonging to open or small a belonging to open minus 1, 4 interval, for which this is less than 0 or this is satisfied. So a should come from this interval, such that a comma minus a lies inside this circle. So it is what? Minus 1 comma 4 open interval. Next question says what? It says that if the line y equals mx, so this line is not intersecting this circle, then, so it is already given to us that this line is not intersecting the circle. That means it is not even tangent, nor is it basically crossing through the circle, intersecting it at two distinct points. It is literally outside the circle. That means if I talk about the perpendicular distance of the line from the center of the circle, it is obviously greater than, strictly greater than the radius. So what is the perpendicular distance of that line from the center of the circle? The center of this circle is minus 10 comma minus 10. And the line is basically y equals mx, which means mx minus y plus 0 equals 0. So perpendicular distance is greater than the radius. What is the radius? Radius is under root 180 whole square. So under root 180 is the radius. This is the center and that's my line. Perpendicular distance of the line from the center is m into minus 10 minus minus 10 whole upon under root m square plus minus 1 whole square. So m square plus 1. This distance is greater than the radius. Fine. So what you get from here is if you square both sides, you basically get this is 100, then this is 1 minus m whole square, because 10 comes out common, you square it, you get 100, 1 minus m whole square whole upon m square plus 1 is greater than 180. So next what you get is, this is 100 upon 180 is greater than m square plus 1 upon 1 minus m whole square. From here you get this is 5 and this is 9. So you basically get 5 times 1 plus m square minus 2m is greater than 9m square plus 9. So this gives you 5 plus 5m square minus 10m minus 9m square minus 9. Now 5m square minus 9m square gives you minus 4m square minus 10m minus 4, because 5 minus 9 gives you minus 4. This is greater than 0, right? You take out 2 common, you get minus 2m square minus 5m minus 2 is greater than 0, or 2m square plus 5m plus 2 is greater than 0. Isn't it? Or I should write over here less than 0. Why? Because I am taking out minus sign common, right? So if minus of this is greater than 0, this term is less than minus of 0, which is 0 itself. So now when you try to open this up, what you get is, this is 4m plus m plus 2 is less than 0. From here you can take out 2m common, you are left with m plus 4, and then you have, this is m plus 2, you take out 2m common, you are left with m plus 2 plus 1 m plus 2. This is less than 0. Again you get 2m plus 1, m plus 2 is less than 0. On the number line when you plot, you basically get minus 2 and minus 1 by 2. And you obtain, this is the region where m should belong to satisfy this condition. So m should come from minus 2 comma minus 1 by 2. Understood? That is the very range of m. Clear? Third question says what? It says that the equation of the circle passing through this point and the points common to the two circles, this is what circle? Now here the concept comes into picture, that if there is a circle passing through the intersection of these two circles, its equation is given by x square plus y square minus 6x plus 8y minus 16 plus lambda times the other circle, which is x square plus y square plus 4x minus 2y minus 8 equals 0. So that's how the equation of the circle is understood. What is the exact equation? For that you have to understand that this circle is passing through the point 1 comma minus 3. So in place of x if you put 1, and in place of y if you put minus 3, you get the value of lambda, right? In place of x you put 1, in place of y you put minus 3. Okay, and this is equal to 0. You solve this, you get lambda is equal to 3. And therefore equation of circle comes out to be x squared plus 3x squared, that is 4x squared, y squared plus 3y squared, that is 4y squared, minus 6x plus 12x. See, minus 6x plus 4 into 3, 12x. So 12 minus 6 is 6. Then you have plus 8y minus plus 8y minus 6y. So 8 minus 6 gives you 2. And then you have minus 16 minus 24, which is minus 40. Okay, this is the very equation of the circle, or in short you can say 2x square plus 2y square plus 3x plus y minus 20. So 2x square plus 2y square plus 3x plus y minus 20 is the correct answer. Next question says that if the line y equals mx plus c touches the parabola which is given by this, then what are the conditions which c is going to satisfy? Now see, if you remember, y equals mx plus c, y equals mx plus c touches the parabola y square equals 4ax when, or I should write lambda, y equals mx plus lambda touches the parabola y equals 4ax when lambda was equal to a by m. Similarly over here I can manipulate the equation of this particular line. It can be written as y equals to m of x plus a plus c. Now a into m is extra, so I remove that. So this is playing basically the role of my lambda, because the equation of the parabola is 4a x plus a. So x plus a, x plus a. This line is going to touch this parabola when lambda will be equal to a by m, that is c will be equal to a by m plus am. It is this condition which is going to make sure that the very line is touching the parabola, which is what, a by m plus am. Clear? A by m plus am. Next question says what? It says that the normals at the ends of the lattice rectum of this parabola intersect at an angle of what? Let's try to find this out. If I talk about this parabola's y square equals 4x parabola's lattice rectum, what are the endpoints of the lattice rectum? A comma 2a and a comma minus 2a. Fine. The equation of the normal passing at this point on this parabola is what? It is given by y minus y1, this is y1, y minus y1 equals minus y1 by 2a x minus x1. So 2a gets cancelled, you are left with y minus 2a plus x minus a equals 0. So this gives you y plus x minus 3a is 0. Similarly, another one, there is another normal which is passing through the point a comma minus 2a. Its equation will be y minus y1 equals minus y1, so minus of minus 2a is 2a, minus y1 by 2a x minus x1. So this gives you y plus 2a minus x plus a equals 0, which is y minus x plus 3a equals 0. If you can very easily get, the slope is, what is the slope? This is y plus x. What is the slope? It is minus 1. And what is the slope over here? Slope is minus 1 or 1 upon 1 basically, I should say, so it is 1. You can see that the product of the slope of these two normals is negative, that means they are perpendicular to each other, so the angle of intersection between them will actually be equal to 90 degrees. That is your answer. Fine. So we just compute the very equation of the two normals and then we calculated the slope. The product of the slopes was coming out to be minus 1, which means that they are perpendicular to each other, therefore the angle is 90 degrees. Next we have that the angle between the tangents drawn from this point to the parabola y square equals 4x is what? Now see, I am saying let the slope of the tangent be equal to m. And the tangent's equation is what? Y equals mx plus 1 by m. It is a by m, but a is 1, so this is 1 by m. Now this is actually passing through 1 comma 4, so this is 4 equals m plus 1 by m, which means 4 equals m square plus 1, or 4m equals m square plus 1. So this is m square minus 4m plus 1 equals 0. Suppose this has two roots, m1 and m2. Then clearly m1 plus m2, sum of the roots is minus b by a, so that is 4, and product of the roots is c by a, that is 1, right? Now what is the very angle between these two tangents? I can say let the angle be theta, then tan theta is m1 minus m2 upon 1 plus m1 m2. But I don't explicitly know what is m1 and m2, what I just know is m1 plus m2 and m1 into m2. So I write down this as m1 plus m2 whole square minus 4 m1 m2. That's how we can write this, whole upon 1 plus m1 m2. Understood? So this is m1 plus m2, that is 4 square, which is 16, minus 4 upon 1 plus 1, that is 2. And this actually gives you root 3, which eventually brings tan theta is root 3, and so theta is pi by That's how we compute the very angle between these tangents, which is pi by 3. Clear? Next question is, tangents are drawn at the points where the line this is intersected by the parabola y square equals 4ax. The coordinates of the point of intersection of the tangents are what? So over here, understand, basically tangents are being drawn at points where this line is intersected by the parabola. That means this line is actually happening to be the chord of contact of the two tangents at the point x1 comma y1. I don't know what that is. Some point x1 comma y1 is there, and where these two tangents are intersecting, and this is actually the chord of contact, right? So what is the actual equation of the chord of contact? It is y1 equals 2a x plus x1. x1 comma y1 is the point at which they are meeting. This is the actual equation of the chord of contact of the two tangents intersecting at x1 comma y1, but it is given to me as lx plus my plus n equals 0. This is given to me as the equation of the tangent. Let me write it in standard form. This is 2ax minus y1y plus 2a x1 equals 0. So obviously both of them are representing the same equation, same line. So what you get is that 2a by L is equals to minus y1 by m equals 2ax1 by n. If you compare these two, what you get as x1 is 2a gets cancelled, x1 comes out to be n by L, and y1 comes out to be what? Now y1 comes out to be 2am by L, or minus 2am by L, right? This is 2am by L and minus sign. So you basically have your very coordinates, that is n by L comma minus 2am by L. This is the point at which the two tangents are intersecting, and Lx plus my plus n is the equation of their chord of contact. Next question what we have is the equation of the chord of this ellipse is bisected at 2 comma 1 is what? Let's see. Now this is very direct. Ellipse is given to you, equation of the chord bisected at a certain point. You know it is equal to, it says t equals s1, right? So it is x1. So x into x1 is 2, y1 is 1. So 2x by 36 plus y into 1, y by 9 minus 1 equals x1 square, that is 2 square by 36 plus 1 square by 9 minus 1. So you basically get 2x plus 4y minus 36 equals 4 plus 4 minus 36. So what is it that you get? You get 2x plus 4y equals 8, or you get x plus 2y equals 4, right? What you get x plus 2y equals 4 or x plus 2y minus 4 equals 0 as the very equation of chord bisected at a given point for the ellipse. Next question, we have the equation of the tangents to the hyperbola this which are perpendicular to this line are what? So let's try to understand this. Now over here, see what is happening. Suppose tangent has slope m. Now this tangent is perpendicular to the line x plus 3y equals 2. What is the slope of this line? It is minus 1 by 3 minus coefficient of x upon coefficient of y, and you know that this tangent is actually perpendicular to this tangent is perpendicular to this particular line. So the product of their slopes is minus 1, right? So what you get basically is that m is equal to 3. Now m is 3. Also, if I am talking about this equation, it is the equation of the hyperbola y, and this I am written as x square minus y square by 3 equals 3 by 3, which is 1. So you get a square, x square by a square is 1, b square is 3. So what is the equation of the tangent? The equation of tangents becomes y equals mx plus minus under root a square m square minus b square, which is y equals mx is 3x plus minus under root a square m square. So 1 into 3 square minus b square is 3. So y equals 3x plus minus root 6. This is what is the equation of my tangents. Y equals 3x plus minus root 6. Clear? Next what we have is that the equation of the hyperbola whose asymptotes are given to you and vertices are given to you is what? And this is pretty simple and nice, that if you know the equation of both the asymptotes, equation of hyperbola becomes what? Equation of hyperbola becomes 3x plus 5y multiplied by 3x minus 5y plus some constant equals 0. That's what is the equation of the hyperbola if you are aware about the two equations of the asymptotes. Now over here understand, it is given that it passes through 5, 0 minus 5, 0. 5, 0, if this passes through, you get 5 into 3, 15 plus 0 into 15 minus 0. So 15 into 15 gives you 225, 225 plus lambda is 0, lambda comes out to be minus 225. When you plug in the very value of lambda in here again, what you get is a plus b, a minus b, which is a square minus b square equals 225. Clear? So 9x square minus 25y square equals 225 is the very equation of my hyperbola. 9x square minus 25y square equals 225, and that completes our discussion over the questions. Please practice them nicely. That's it from my side. Thank you.